Hey everyone, my name's Asin Huddy, and this is episode 8 of Apache Geode by Example, and we're going to talk about serialization. I said earlier this week in a tweet that we'd probably talk about Spring Boot data Geode that just got released, but looking at kind of where we are going through the examples, I feel like we gotta eat our vegetables before we can have dessert. And looking at Spring, we're gonna look at serialization first, and next week we're gonna look at Spring Data Geode for sure. Now, serialization is a pretty difficult problem in computer science. It seems like just on a regular cadence, there's a new serialization library out there. There's Avro, there's Thrift, there's JSON, there's JSON Schema, there's Captain Proto, Google Protobufs. There's a lot of ways to approach this problem, and I'm gonna lay out the 3 ways that Geode approaches this problem, and I'm gonna give a recommendation on where to start. We're gonna give an example of that recommendation. So any data that moves from the client to the server, it needs to be serialized to get over that wire. And then if we want to do things like querying that data, that information has to be deserialized. Now that can be really costly and hurt latency and throughput. And Geode does a really careful job at managing when to serialize, when to deserialize, and be efficient. Now, the 3 ways to do serialization, there's Java serialization, but the kind of built-in serializable interface in Java we found to be too slow, but it's really approachable. Don't recommend going down that path. There's data serializable, which is a library that gives a really compact format for the data, but it doesn't include all that metadata and versioning that becomes such a big problem with sharing data in a complex distributed system. So the approach and the technology that's in Apache Geode is a data format called PDX. And the reason I giggle a little bit, it stands for Portable Data Exchange. It also happens to be the abbreviation for the Portland International Airport, and Portland is where a lot of the Apache Geode development happens. And what PDX solves is a lot of the big challenges around serialization. It handles forward and backwards compatibility, so that versioning is in there. It handles that metadata. It includes all the metadata around that object, and that moves with the object. So another client doesn't have to have the information about that object to deserialize it. And if you're working in a big, multiple teams are working on problems and have different clients, sharing that information can be really challenging and keeping everything up to date, and PDX solves that. There's a really great article, I'll link it down in the description below, that talks about PDX in detail. And you can see in this graph that the data serializable class, it is more compact and it's more efficient, but there's drawbacks to that. And it's mainly around versioning, having to upload the classes on the class path when you upload to the server. PDX, you don't have to do that. And furthermore, we can rely on reflection and not pay that big of a penalty when we implement PDX. And we're going to look specifically at that in our example today. And that is the recommended first approach when working with Apache Geode, is relying on PDX and the reflection-based auto serializer before trying to optimize the system implementing PDX serializable on your classes, or going even further and using data serializable. So let's check this out. Those are the three approaches. We're going to look at the reflection-based auto serializer. Really quickly, they're gonna see two things here: serializable and serializer. Serializable means you have control over those objects. You've created them. You can implement the serializable interface onto that object. Serializer means you've been given an object. You can't define it in any way. It's already there, and we're serializing it. So that's the difference between serializable and serializer. Let's take a look at the example. So this is the serialization example in the examples repo. We have a country object, and the first thing we're going to do to take advantage of reflection and PDX is we need a default constructor. And we can see that we have a couple parameters and some getters and setters method, and down here there's a little toString method that's going to allow us to print it out. Now, with the example, we're going to create a cache and a region, and the only thing we need to do in order to take advantage of this reflection-based auto serializer is pass in this line here. This set PDX serializer, we new up the reflection-based auto serializer and pass in the name of the domain object that we want, and we could put a star here and pass in a wildcard to capture more of those objects. And we have some helper methods down here, and we create these objects. And all we're going to do is insert some objects into the cache, and then we're going to get all the keys, iterate through them, and print them out. All right, now let's take a look at this. Up top, I have the examples, and below I have gfish, and we're going to need gfish in a second. So if I pop up here, first thing I'm going to do is I'm going to use Gradle, and I'm going to build this example. Alright, I made some additions, so I got to run spotless, clean up what I have here. And oh, really quickly, our region, where's our region? So countries, we have this object, and we're using the region interface. Really how it was designed to be used, to have a way of modeling our data. So instead of, I've seen a lot of times a given cluster will be divided up amongst different teams with the region API, and then they have to those different teams have to manage that, all their needs in that given region. And we're not taking advantage of modeling our data with regions. So countries in a given region, a person object in a given region. So having more homogeneous region types is a great way to help model our data. Going back here, so we built our example, and instead of using the helper script, I'm just going to run this example down here and start things up. So we're going to start a locator, start a server, create the countries region, and then we're going to use gfish to do some queries on that. And what's great about having the metadata along with the object is we don't have to deserialize the entire object when we want to just get a particular field in that object. Now, if we didn't have that information, we would have to deserialize the entire object, then look through it, and that operation can be very expensive. So there's trade-offs of using the different serialization methods, but PDX has a lot of built-in optimizations that in the long run you're benefiting in terms of team coordination, in deserialization and serialization efficiencies that we believe in 90% of the use cases really pays for itself, especially and holistically. All right, so now we have our countries region created, and we can go ahead and run this example. So pop up here, and we're going to run this, and we should see some data that was put. And while that's so that happened up here, we have those country information. And what's great is we can pop into GFish, and we're going to remember to connect because I always forget to do that. And we're going to issue a query. So that query, so the country information, I think we had population. So let's select population from our countries region. Now what's great here is when we issue this query, we didn't have to deserialize each one of these objects. We just had to deserialize the population field because that metadata is there. So in summary, PDX first, use reflection first, where you know, and only optimize later on when maybe the system becomes more stable. Objects aren't changing as much, but reflection is definitely the way to go. PDX is definitely the way to go. I hope this was helpful. And next week, as I mentioned, we're going to talk about Spring Boot Data Geode. I'm really excited about that, and I'll see you next week.